Hello viewer and welcome to the e-learning classroom. So today we want to look at diffraction of waves. So we want to know what is diffraction of waves, and it's important to note that when we are talking of waves, we are referring to any type of a wave, whether it is a mechanical wave or whether it is an electromagnetic wave. Remember, there are so many types of waves. We have microwave, gamma rays, X-rays, sound waves, water waves, and so many other types of waves. So we want to know how waves are normally diffracted, and it's important to note that waves are normally diffracted when they pass across a barrier or when they pass across an aperture or a narrow opening. And it's also important to note that when diffraction occurs, it's only one variable that changes. What changes is only the direction. Only the direction of the wave that changes, and all the other factors do not change. So what does not change includes, we have velocity does not change, or wavelength, velocity or wavelength. Another thing that does not change is frequency. Frequency of the wave does not change also. So let's look at these 5 diagrams to know how the waves are normally diffracted. So we are going to start with a wave passing through an obstacle. So you can see there is an obstacle here, and then there is a plane wave that is incident on the obstacle. So the first wave is going to pass through the middle here. The first wave through the middle. The second wave, remember the wavelength does not change. Remember the wavelength does not change. So we have the second wave. The second wave passing through there. We have the third wave. The third wave, longer. We have the next wave. We have the next wave, similar wavelength. We have the next wave. Maybe you can also draw the last one. The last wave still on that part. And then each wave is curving slightly. Each wave is slightly curving. As a result of the influence from the obstacle, and then this wave again is still moving in the same direction that was the incident wave had. So the wave is still moving in the same direction of the incident wave. That is the direction of that wave. So let's look at the second one. The obstacle is now in the middle. The obstacle is now in the middle of the wave. So we want to see how the waves are normally diffracted for this case. So the first wave will pass through the middle. The first wave. After passing through the obstacle, we have the second wave. We have the second wave, we have the third wave. The third wave, the fourth wave. Then maybe lastly we can draw the sixth wave. We can draw maybe the last wave for that purpose. Then again, Each wave is slightly curving. Each wave is slightly curving as a result of the influence of the obstacle. So that's how the wave proceeds after passing through the obstacle. Let's look at now the waves passing through a narrow aperture, a wide aperture, sorry. We have a wide aperture. So this first wave will pass through the middle. So we have the middle there, a wave. From there we have the others now. Wavelength must remain. Oh, sorry, I think I've drawn the wrong one. So the other wave through this part here. Then we have the next one. Then the next one. Then the next one. Then the next one. And so on and so on. So this wave is slightly curving. Slightly curving. But these are plane waves. So these are plane waves but slightly curving. You can see that, plane waves but slightly curving. Then we have these other waves passing through a narrow aperture. We have a narrow aperture. We want to know how these waves will pass. So because the aperture is narrow compared to the wavelength, the aperture is actually narrower than the wavelength. So you realize that these waves becomes circular waves. That means now the waves will have this kind of shape. They now become circular waves. So that is how those waves pass through the aperture, because the aperture is less than the wavelength. The aperture is less than the wavelength. In other words, if we call this distance from here d, from here up to here, if that distance is d, and this one wavelength from here up to here, then it's important to note that d is less than wavelength. D is less than wavelength. So let's now go to the last one, whereby we have a very narrow aperture. The keyword is very, very narrow. So the keyword is very. So in other words, the distance of the aperture is very narrow compared to the wavelength. So for this particular case now, what happens is now what we call interference. In other words, two waves will come out, and that means we have the first wave and another wave here. Circular waves, those are two waves. For the first wave, we have another one. For the second wave, we have another one. We have for the third wave, another one there. Then we have another one for this side. We have another one for this side. Then we have, oh sorry, this this one is round. This one is supposed to come from here. Then we have another one for this one.